in a single replacement, something that is by itself kicks out something that is in a compound. The thing that was by itself goes into the compound, the thing that was in the compound falls out of the compound and becomes by itself. So in this case, the sodium kicks out the hydrogen drops out and becomes H2 gas.
Wait, why does the sodium take out the hydrogen?
Because the sodium is more active than the hydrogen.
Oh,
In other words, more popular.
more popular.
Oh, you're not. Are we having a test on this tomorrow?
No.
Oh, but we don't have an exam.
But it is, there are balancing and reaction types on the final exam, on the semester exam. Okay, so is this balanced?
No.
How can we balance this?
Oh wait.
Okay, guys, take a look. Look at this.
Got it. 2, 2, and then 2. And then leave it.
Okay. This is really important. Are you paying attention?
Yeah.
If you're not paying attention, you're not going to get this, and you're going to be like, am I the only person that doesn't get this? And we're all going to say, yes. So this is hydrogen and hydroxide.
Okay.
How many hydrogens do you see right here?
2.
If by 2 you meant 1, you would be right. There is 1 hydrogen. The other one's the hydroxide. So we have 1 hydrogen here. The other one's a hydroxide. 1 hydrogen here and 2 hydrogens over here. So we double this. Now we have 2 hydrogens.
You also have 2.
How many hydroxides do you see?
2.
2. How many hydroxides over here?
1.
1. Double that. How many sodiums?
2.
How many sodiums? And we check.
Boom, already got it.
2 sodiums. 2 sodiums. 2 hydrogens. 2 hydrogens. 2 hydroxides. 2 hydroxides. And we're balanced. Okay. Now you didn't see this when I opened it up, but this is crazy. The sodium is stored in mineral oil to protect it from the air, because it reacts with air too. The sodium is stored in mineral oil. Then this bottle is put in a bag. Then this bag is put in this clay sand. And the clay sand is put in a can. Then the can is put in a big bag. They really don't want this stuff reacting without on its own. So I'm going to cut the sodium here. Got a pretty good chunk right up in here.
This is like pure sodium.
This is pure sodium metal. Yeah, pure sodium metal. And it's all gray and oxidized. But if you cut it, can you see this in the front row?
Whoa.
Yeah, can you see how shiny this is? I've been telling you this is sodium. They're like, but sodium is like salt. No, sodium is a metal.
Is it salty enough?
If you tasted it, it would feel like fire.
Why would it feel like fire?
Because
So
it
you
reacts
say
with water in your mouth.
Okay.
Spicy.
Now I'm going to put this sodium in my little cylinder here. Now there is a bunch of pieces of sodium still hanging out in there. Unfortunately, there's this crazy emulsion. Let's see if this one does any better. So this is mineral oil and this is water down here. And what happens is the sodium goes down and it touches the water and reacts with the water and makes bubbles. Sometimes. There's the bubbles coming up.
Whoa.
See the bubbles coming up? Beautiful. Yeah, so these bubbles are hydrogen gas. Unfortunately, there's this cruddy emulsion right here that's just getting in the way. So we're going to go outside, and we're going to do it. I'm going to split this into a couple pieces.
Can I pour the water?
We're all going outside.
Oh yeah.
No, give me my brush. They look better on
Let me clear your piece up.
Oh, Pete's. No, I thought maybe with the camera. No. No, you definitely never. I would get in big trouble if I allowed you to touch this stuff.
Is it
No, like, I'll just
burn
hold
you
it.
or hurt you?
Stop.
Where's the water?
Yes. It will react with the water in your skin. Well, I mean, if you have oil around, you should be okay. But again, it's just generally bad form to.
Why don't you find out? Why don't you find out? It'll burn your taste buds off.
I'll try to king cut you. What will happen is it'll explode and the metal pieces can hit you and kill you.
Oh.
Or not kill you, but hurt you.
Yeah, room temperature water, right? I forgot my little. I need to get one more thing. Yeah, no, we're okay. Now, this is what's going to happen. I'm going to put a piece of sodium in the water. The sodium's going to react with the water violently. It's going to melt the sodium and release a lot of heat. Now, what's going to happen is a little bit of hydrogen gas is going to be made where the sodium touches the water. That's going to cause the sodium to cruise around on top of the water. Now, if it gets hot enough, the hydrogen will burn. If it gets really hot, the hydrogen will cause the sodium to explode, which is why you're really far away.
Sizzles.
So right now, it's melting the hydrogen, producing a lot of heat, and then sometimes it gets hot enough to light the hydrogen on fire. Sometimes I light it myself, but I don't want to right now.
I'll do it.
I know you will.
Whoa!
All right.
Okay, so you saw the bits of stuff that came off right here?
Brenton, touch it.
Was that where the spot Brenton, go.
Brenton, lick it.
Oh.
Yeah. If this got on you, you wouldn't have been happy.
Oh god.
So what is that white stuff?
Sodium oxide. Sodium oxide. Now we're going to do one more. You ready for the next one?
Well, it's a bigger piece.
Yeah.
Yeah, I'm ready for
It's
this.
sodium reacted with water.
So
And
then
then you can see the steam coming up.
can,
So
bro.
it's very hot. And then what you can't see is the hydrogen gas that's being produced. And then the sodium is melted. And usually it gets hot enough that the sodium itself like sets the hydrogen on
What if
fire.
you put like a pound in the pool?
It would burn your house down.
Oh, it's burn our house down if we put it in the pool
Because it would
outside.
explode, sending pieces of hot sodium towards your house, which would then set your house on fire.
What if we did it in the lake? The lake. Would it be fine?
You can do it in the lake, that's fine.
What? He's like, that's what I'll totally do.
Well,
I'm gonna do it. Dry ice bomb way of
boiling water.
Wouldn't recommend it.
Fastest way to make mac and cheese.
Okay, so let's go back inside.
I have a question.
You guys wanted to explode. I know you guys wanted to throw shrapnel all over. I'm actually pretty thrilled that it didn't actually explode that much. What's really fun is when it rains, you can see the pieces of sodium. They're like all over the place.
I'm guessing you don't want to use water to put out that fire. So how do we get that? Yeah, no duh.
Wow, thank you.
You buy it on.
How much is it? What kind of mushroom was that?
Mr. Marsh, could you get a hold of potassium by any chance?
Bananas.
That's
I looked it up, Mom.
I love
why aren't you lithium? That's fun. Let's do you have any lithium batteries? Nah, you probably just have lithium. Nice.
Alright, so ladies and gentlemen, one more single replacement reaction. Okay. This is a solution of silver nitrate, which is interesting stuff. It's got some silver ions in solution. Yeah, this is just bubbles here. Yeah, you can use this to make mirrors, and I have actually. A mirror. And then this is just a copper wire. And what I'm going to do is I'm going to put this copper wire into the test tube full of silver nitrate. It's something kind of interesting happening. There we go. I'm going to set it right here.
We do this again.
So silver is Ag. So we got silver nitrate, and it's aqueous. Remember what it means when something is aqueous? Yeah, dissolved in water as ions. So what really exists here is silver ions and nitrate ions. And then into it, I put a copper wire, which was solid. And this is a single replacement. So since it's a single replacement, what's going to happen? Copper's going to kick out the silver. The copper's going to be like, see you later, silver. I'm more popular than you. So the silver comes out then. The silver comes out of solution, forming a solid. And the copper goes into solution, forming copper 2 nitrate, which is going to be aqueous. And it's doing it right now.
Could we do silver thermite?
I suppose. Yeah,
I want
no
to see
silver.
something explode.
Can you see what's going on to the wire up here?
Yeah, it's kind of a little darker.
If you're up front, you can see little crystals of silver forming on the copper wire. It's going to get fuzzy.
So how much is
Fuzzy.
this, how much money does how much does it cost to get this silver solution?
A container of silver nitrate, like a small, like 100, like 20 grams is like about $80. So
How
it's
much-
ridiculously expensive.
How much was the sodium?
Less, but around.
Did you have to have a permit or something to buy it?
Yep. Okay, so could you balance this, please, before we do the next version?
I'm balancing.
That's what you're saying.
Already balanced.
It's not already balanced because there is 2 nitrates on the right side and 1 nitrate on the left side.
So I did nitrate to the left side.
Good, it's done. So it's 2 AgNO3 plus Cu goes to Cu. Got it.
Yeah, it's 2 in front of there and 2 there.
Where do you want to put it to?
In front of the end, in front of the whole thing.
In front of the whole thing, the silver nitrate, 2 there.
Yeah, and then in front of the silver on the other side.
In front of the silver here. That's it? Let's see. 2 silver, 2 silver, 2 nitrate, 2 nitrate, 1 copper. What?
Whoa, you can actually
Are you making fun of me? Okay, so I'm just gonna let this go. This is pretty cool. You actually, if you're in the back now, you can probably see that the silver crystals are coming out of solution and forming on the copper wire.
It's
pretty.
So if you do this long enough, with enough like copper in there, you do the other thing and put something else in it and then cover it out with copper. And then
Yeah, you can totally do that. If you put sodium in there, the sodium will pick up the copper. All right, next. So these are all single replacement reactions. Double replacement is what we call it when you switch partners. Okay? In a double replacement, you switch partners like so. And what's really important about a double replacement reaction is, guys, is positive things will swap with positive things, or negative things will swap with negative things. But a positive cannot swap with a negative. This is potassium iodide.
So are you making a solution or an aqueous?
I'm sorry, what?
Are you making like a solution?
Yes.
No, what's special about the lab water? Just water.
Has less minerals
Oh,
than,
it's distilled or
yeah.
Not Boulder water.
It has less minerals than Boulder water. And there's lead nitrate. Yeah, it's Boulder water. The lead in the lead nitrate would react with Boulder water because Boulder water has a lot of magnesium and calcium.
and a cool reaction like explode or
No, it would just make it cloudy.
it's not like that.
Drink up, kids. Okay, so I'm going to give Chloe the lead nitrate, and I'm going to give Chloe the potassium iodide.
Oh my gosh. Okay, but
So-
she made like I guess I have to. I don't know.
So
Wait,
Chloe has lead nitrate.
wait,
which
which
is
Chloe?
PbNO3, 2, and Chloe has potassium iodide, which is Ki, and these are both aqueous. And what's going to happen is the metal is going to swap with the metal. Now, what's the metal in lead nitrate? Lead. What's the metal in potassium iodide? Potassium. So they're going to swap, and what's going to be made is PbI2, which is going to be solid, and then KNO3, which is going to stay aqueous. So go ahead and balance that, unless you're one of the Chloes.
Okay.
You can balance it afterwards. Actually, you can balance it now. You're fine. You're safe. You can balance it now. Don't drink it.
Boom,
I
done.
don't want to.
Done.
I don't want to turn solid. Oh god.
But aren't them if they're solutions, aren't they ions? But potassium nitrate's not an ion.
They're both. These are all ions. So what you're actually seeing, again, good point. What you're actually seeing here is lead ions, which you can't see, and nitrate ions, which you can't see, and potassium ions, which you can't see, and iodine ions, which you can't see, and it's going to make chunks of PbI2, which you will be able to see, and then more potassium ions and nitrate ions, which you can't see.
But you can, but they have potassium nitrate you can go buy.
Yes, yes. This is potassium nitrate. You can go down to the local vitamin store and buy some potassium nitrate.
Or you can just go on Amazon and get some stuff.
Yeah. Okay, so when you're ready, go ahead and stand up, and one of you pour your test tube into the other person's test tube. So everybody can see it.
Are you gonna make it a hot one?
Oh yeah, you want to move the camera?
Well, we can.
Whoa, look at
Did
this.
somebody pop the thing? There we go. Now it's looking at you.
Tell me for it?
Oh jeez.
Okay. It's not really like floater.
Somebody tried to fix it.
How do you know?
No.
What? Oh, it's yellow. Gross.
So that's
Wait, I can't see.
lead
Ew.
Drink it. I dare.
Don't drink it.
Drink it!
How much money are you betting?
No, do not drink it. Okay, so why don't you give that back to me?
I'm not gonna drink it, even though no, I'll bring you $20.
That's how bananas get their cup money.
Okay, you drink it. I'll call 911. You know, like you probably haven't seen this color before. This is actually
like highlighter stuff.
this is lead. This is the dye they would use in lead paint. So you know, like you used to eat paint chips. Well, they used to use lead as a pigment in paint because it gave you crazy colors. And this would be what they would use for the yellow for lead in lead paint. Until they realized that lead was bad, and they didn't, you know, toddlers were eating it and it was getting into their food. So that's double displacement or double replacement.
Wait, so could you use that as paint?
Yeah, you could use that as a dye. You could dry it
Oh,
out
as a
and put
dye.
it in alcohol, use it like paint your whatever with it.
That's dope.
So 2 nitrates here. How many nitrates over here? One.
We need double
So
that.
put a big 2 up there.
And double
2
the
potassiums.
double the potassium. and we're
2
good.
potassiums. 2 iodines, 2 iodines, 1 lead, and we're balanced. Okay. How are we doing so far?
Good.
Muy bien. All right. Can you ever have a negative? Can you have a positive swap with a negative?
Yes.
No. Okay. In a double replacement, only the positive swaps with the positive. So A would swap with C, and you'd get AD and CB. A cannot swap with D. Okay. And B cannot swap with C. Does this make sense?
Yeah.
Okay. So I think this is a pretty good place to stop. So we'll go ahead and stop there. We got a few minutes of extra time.
Can I hold the top?
Yes.
I don't have any